Okay, today we're going to continue our discussions in Unit 10 with beginning to look at composite solids. You have to see there's a wide variety of shapes that can show up as far as composite solids are concerned. The same as we saw, there's a wide variety of things that we could find with composite shapes when we were doing area of two-dimensional figures. Well, we got a whole bunch of different three-dimensional figures, so obviously we're going to be able to build a whole bunch of different three-dimensional figures. And imagination is going to be an important thing to have when it comes down to looking at these things. Okay? The work we're going to begin today will be the same in a lot of ways as the work we did with composite polygons. That's just kind of what I just said. Okay, the most critical part of solving the problems is going to be figuring out how to begin them. And the answer to the question how to begin them is going to be much the same as we did when we were doing area a couple of units ago, is figuring out a way to describe them. Can you put the shape that you're looking at into plain English? If you can put it into plain English, then chances are you can match up what you're thinking with formulas that'll go along with that. And then hopefully we'll be able to get our information into the formulas and do our calculations. Okay, well, I've got some example solids that I want us to look at. Okay. First, here's a solid. And copy it down if you feel like it. If not, just follow along with. Okay. We're going to put this thing into plain English. If we can put it into plain English, then when it comes time, we'll probably be able to figure out what formulas go along with that. Okay, so can somebody describe what this thing is? What we're looking at here is we have a rectangular pyramid, okay, on the top part, but underneath that, it appears to be a rectangular prism underneath it. Okay, so when it comes down to it, what we have is we have a rectangular prism being added with a rectangular pyramid. Okay, that's a reasonable description of what that yellow figure shows right there. Okay. Let's have a look at this green one. Seems pretty clear by looking at this that on the left-hand side of this figure we have a cylinder. It's turned over on one of its lateral faces, so its bases are left side and right side. And on the right side of it, it appears that we have a cone, okay, probably of the same radius attached to it. So a description of this one would be a cylinder plus a cone. Here's where the diagrams get a little bit more difficult. Okay, and some people have a lot of trouble seeing seeing in their mind what they're seeing with their eyes. Okay, so have a look at this one. Record this part. This one's a little bit more tricky, okay, because this one's dealing with a cutout. Okay, something is missing from this overall picture. And you can see the color variation down on the bottom side where you can kind of see that light blue inside of the aqua or whatever color this rectangular prism is. Okay, and that doesn't mean that we're seeing all the way through the figure. Okay, that discoloration, what it means is we're seeing inside of the figure, not necessarily all the way through it, but we're seeing inside. There's a cavity inside of this rectangular prism. Now, paying attention to just the cavity itself, okay, which means kind of looking at that opening and looking at the dotted lines that are inside of this whole figure, what kind of a shape does that cavity appear to be? Isn't it another rectangular prism? So look, I mean, basically, to put it in plain English, do we have a box on the outside, but then inside we're missing a smaller box? Yeah, that's it. That's probably in plain English, that's what we got a box missing a box. Okay, so to put it in geometry language, that would be we have a rectangular prism minus another rectangular prism. Okay, that would probably be the best technical way to describe what that figure is. Okay, prism, rectangular prism minus another rectangular prism. And these shapes can get quite creative. Okay. This one underneath, it should be pretty easy to see that there is a triangular prism, okay? And underneath, or on top of that triangular prism, we appear to have half of a sphere, and the term for that is hemisphere. And then the last one I threw together was this little gray one down there. Let's take a look at it. Okay. Looking at this solid, we can see that we have some discoloration. Okay, so what does that discoloration tell us? Yeah, something's missing. We are seeing to the inside of this figure for some reason. Okay, and that reason would be because there's a cavity. Okay? Now, where is the cavity actually at? Well, we can see it on the top side, and we can see that connected to that top side, we can see a bunch of dotted lines, which means that cavity is dropping down inside. Well, let's just describe, what's the overall figure look like? What's the, yeah, the overall figure appears to be a cube, or at the very least, a rectangular prism of some kind. Okay. What does it appear is missing from our cube? Yeah, it looks like we've got a square or rectangular pyramid that has been cut out of it. Okay, so if we were trying to put this into English or put it into a formula, it appears to be a cube minus a pyramid. Okay, and it may not seem like it at this point, but guys, if you can get to that English, if you can get to that sentence that describes the math, as far as I'm concerned, that's at least 40% of the problem, if not closer to 50% of the problem. From here on out, it's just a matter of doing math that we already did in Unit 9. Okay, so let's see if we can take a look at some of these figures. Actually, I have all of these figures again with some measurements to go along with them. And let's see if we can calculate some volumes based upon those measurements. Okay, so here is this figure. How did we describe this figure a moment ago? Rectangular, you said rectangular prism plus a rectangular pyramid. Is that what you said? Okay. All right, so that's all right. So that sounds like a good place to start. Prism plus pyramid. Okay. Sounds like an equation to me right there. Okay, and this is volume. Volume equals prism plus pyramid. All right. Okay, you've already got, like I said, 40, 50% of the problem done by identifying that it's a prism plus a pyramid. Okay, now all we need to do is go, okay, I need the volume of a prism. I need the volume of a pyramid. Well, you've got formula charts. Let's go to the formula charts. Let's get the right formulas, and let's bring them to our paper. How do you find the volume of a prism? Big B, little h, right? And big B stands for what? Okay, area of the base, and little h would be the height of the prism. Okay, that needs to be added to the volume of the pyramid. Okay, so let's go back to our formula chart. Let's find out how we find the volume of a pyramid. Okay, 1/3, big B, little h. Okay, once again, big B is the area of the base, where little h is the height of the pyramid. Okay. Now this is the point where in Unit 9 we go, okay, let's stop and take inventory here. Okay, take stock of what we do have or what we may need to find. Okay, so big B for our prism. Okay, well, let's look at our prism. We need to decide where the base is. Okay, well, when it comes down to rectangular prisms, we can put the base pretty much anywhere we want. So how about we just let it be sitting on the base right now? Okay, the bottom side can be the base. Okay, bottom side, it's a rectangle of some kind. In order to find the area of a rectangle, you need the base and the height. Okay, do you have those two different sides of your base? Yes, we do. They're 4 and 4. Okay, since we do have that, I'm going to go ahead and plug that in. Okay, our base of our rectangular prism is 4 by 4. Okay, how about the height of the prism? Have we provided the height of the prism? Yeah, remember the height of a prism is just the distance in between the bases, how far they are apart. And we are provided that with the 6. There we go. Okay, so we're good to go on the volume of the prism. All right. To that, we're going to add 1/3 as part of the formula, so it's definitely going to be there. Now we need to know big B for the pyramid. Okay, well, big B is still the area of the base. Okay. Yeah. Well, with a pyramid, the base is simply the one side that is not a rectangle or not a triangle, right? Okay. So look at the base. It would be the side that is sitting in between our pyramid and our prism. Okay, that's where they're kind of glued together right there would be the base of that pyramid. Okay. Well, once again, isn't that the exact same as the base of the prism in this case? 4x4. Okay, so that was nice that that happened. That certainly isn't the typical case. Don't think that's always going to be that way or anything. And the height of the pyramid. Okay, 11. Yeah, 11's the overall height. Yeah, there you go. Okay, if the overall height is 11 and 6 of it is used up by the height of the prism, then how much does that leave left over for the height of the pyramid? Yeah, that's 5 units. 11 take away 6, there's 5 units left over. Okay. Now, my guess would be that this is a kind of a pretty typical problem. Okay, it's already multiple step. There's already a lot of things to consider and keep track of. So they're probably not going to make you solve for much. You will probably be given most of the measurements that you need. You may have to find maybe one piece of missing information. The rest of it is just going to be kind of keeping track of everything else that's going on. Well, as it turns out now, I mean, we've got an equation that we don't have any variables in it. We've got all the numbers that we need. We were able to find everything. So let's just clean it up here. 4 times 4 is 16 times 6 would probably send you to your calculator or at least doing a little scribble work on your paper there. 16 times 6 is 96. Okay. Over on the right side, well, again, 4 times 4 is 16 times 5 is 80. And then 1/3 of 80 does not go in nicely. Okay, we've got 80 divided by 3. And that probably will send us to our calculators to figure out what the result of this calculation is. We've got 96 and we've got 80/3. Okay. And our calculator gives us 122.6 repeating. What is that 0.6 repeating? It's a fraction. What fraction is it? Okay. Okay. 0.6 repeating is 2/3. Okay. And there's your answer. Okay. The only thing left to do is identify the units of measure, yards. And we're calculating volume here. What dimension is volume in? Third dimension. There you go. Volume cubed. And you're done. Okay. That is how this works. But as you've already seen, the shapes can change pretty drastically from one shape to the next. So let's look at the next one. How did we describe this one? Cylinder plus cone. Volume equals cylinder plus cone. After we have that description, that would send us to our formula chart. Okay, so let's go to our formula chart, find if we have a formula for volume of a cylinder. Okay. Yeah, a cylinder is nothing more than a fancy prism. Okay, so it still follows the big B little h formula. How about for a cone? Yep, cone is nothing more than a fancy pyramid. Okay, so this formula is identical to the formula that we worked with on the previous problem, even though the figures are drastically different from each other. Okay, well, let's start taking stock here and see what we have. Looking at the cylinder, big B. Okay, obviously our cylinder, okay, its base is a circle. How do you find the area of a circle? Pi r squared. And if I were you, my advice would be to change big B into pi r squared. Actually change the formula to match the shape that we've got going on rather than trying to do too many steps in our head at once. That's when we make silly mistakes. Okay. Same thing on the cone. Big B is the area of the base. Well, it's a cone. Our cone has a base that is a circle. So we need to know the area of a circle. Well, it's the exact same thing. Pi r squared h. So all I did there was just kind of transform the formula to match the shape that we have going on. Okay. Now we can plug in for the variables a little bit easier. Okay. Well, let's see what we got here. We got pi r. Okay. What's radius in this particular case? 4. Yeah, we're given a diameter of 8 feet. Radius would be half of that. So we've got 4, and it's going to be squared. How about the height of the cylinder? Okay, remember height just simply means how far the bases apart from each other. They are 4.5, that's right. Okay, then we got a plus sign, then we got a 1/3, then we got a pi. And as it turns out, by the way these two guys are connected to each other, they should carry the same diameter, which means they'll carry the same radii. Okay, so we got 4 again, squared. And height of the cone. Yeah, we got 7 feet, okay, all the way from left side to right side. 4.5 of those 7 feet are used up by the cylinder. So the question is, how much is left over? 7 feet, take away 4.5 feet of that. That'll leave you with 2.5 feet over there. Well, once again, they didn't hide too much information from us. Okay, so we've got all of the information that we need. It's calculator time. We've got pi times radius squared times 4.5. That'll be added to 1/3 pi radius squared height. Okay, that's a bunch of junk in there. Okay, and you might want to break it down into smaller pieces, maybe calculate the volume of the cylinder first, calculate the volume of the cone second, then maybe add them together if you feel better about breaking it into smaller chunks. That's fine, but if you're more confident in your calculator skills, then you might be able to do it all in one fell swoop. And when I say confident in your calculator skills, that doesn't mean I push buttons on the calculator and cross my fingers and hope the calculator knows what I'm doing. Okay, that's not calculator skills, that's wishful thinking. Okay, so we got 268.08 what? Feet, cubic feet. There you go. Okay. So there's that one. Okay. Okay. All right, let's have a look at this next one. Okay, well, we're provided with a little bit of external information this go round with it. And the more complicated the shapes get, the more you're probably going to see that happen. If there's just the problem, I mean, the problem's already complicated enough, the diagram's already, congested enough. They're liable to identify the shapes for you in written form. Okay, partly like this one did. The larger shape is a cube. Okay, fine. The larger shape is a cube. Okay, so now that we know that, let's combine that information with what we said earlier on this figure. How would we describe this figure now? Okay. If the larger shape is a cube, what happens to the cube? It's missing something. So this time we got a subtraction problem, and it's missing a rectangular prism. Okay, so that would be our basic English equation describing what we're looking at. And then we would convert this into a mathematical sentence. Okay, volume equals what? Well, how do you find the volume of a cube? Yeah, that's it. All we have to do is take a side or an edge measurement from the cube and cube it, right? Because length times width times height is basically what we do to find um, um, volume of a rectangular prism. Well, when it comes down to a cube, length times width times height is all the exact same measurement over and over and over again. So all we need is one side of the cube to cube it, okay? And how about the volume of a rectangular prism? Big B little h again, okay? All right, so let's see if we can fill in some of the missing information here. All we need is one side measurement of the cube, one edge measurement. Do we have one? Yeah, we've got a 7 in there, okay, which will be cubed here in a moment. All right, rectangular prism. Okay, again, with a rectangular prism, we have pretty much free reign to decide what we want to be the bases. Probably the easiest thing just to say, okay, I'm going to let the top and the bottom be the bases. Okay, so what are the two measurements of our bases? Yeah, 3 and 2. And you got to just kind of watch out. I mean, you got some external information kind of floating around, and that will happen, again, especially as the diagrams get more complex and they won't be able to fit everything inside of the diagram. But it looks like our base is 3 by 2. And this actually seems a little strange because right now we are calculating volume of something that's not actually there. Okay, we're basically calculating the volume of that air that's inside of there. We need to remove it. Okay, so 3 times 2. And the height of that air that's inside of there? It's 7, right? I mean, it seemingly passes all the way through the cube, so it should have the same height as the cube itself. So seems like that's a 7, even though that was an ugly one. Okay, 7. And now we just got numbers. Let's just figure this thing out. 7 cubed is probably a number most people are unfamiliar with without going to the calculator. Does anybody know it offhand? It's 343. Okay, let's see what we have to remove away from 343. Got 3 times 2 is 6, times 7, 42. Okay, so what's 343 take away 42? 301. 301 what? Cubic inches. Okay, cube minus prism. There we go. It can seem a little challenging at first, but hopefully you're seeing it. It's not all that difficult sometimes. Okay, it's just a matter of working through the formulas over and over again. Let's look at the next one. As you can see in this case, again, okay, the more complicated the figure, okay, especially when they start using fancy things like hemispheres and stuff like that, they're probably going to be providing us with some external information. The prism has regular bases. The hemisphere has a great circle of 25. Well, that sounds like it's going to complicate matters a little bit. Okay, well, how can we describe this thing? Okay, volume equals a triangular prism plus a hemisphere. Okay. Well, let's see if we can figure that thing out. How do you find the volume of a triangular prism? Yeah, still big B little h. Doesn't matter what type of a shape the prism is. It'll change big B and how we find it, depending on what kind of a shape the base is, but it's still big B little h. How about the hemisphere? All right, well, in the formula chart, as we just said, we have a formula, 4/3 pi r cubed. However, what does that formula represent? The full volume, right? Okay, we're not looking at an entire sphere. What exactly are we looking at? Half of one. Half of one. So what can we do? How can we adjust that? Easily enough. We don't want the entire sphere. We want half of it. Okay? And you may be forced to make some adjustments to some formulas that way. Okay, let's see if we can figure out if we have all of the necessary information. Okay. Big B. Big B represents the area of the base. Okay, the area of the base of our prism. Okay, well, what kind of a shape is the base of our prism? It's a triangle, right? Okay, what do we know about the base of that triangular base? Not much. Okay, all we know is the problem says that the prism has regular bases. Okay, so what does this term mean, regular? Yeah, we're equilateral, we're equiangular, okay, and probably most importantly for now, what that means is all of our sides are the same. So I'm going to actually pull a triangle off of that, okay, pulling that off of the base, and we have one side of our base being marked as 10 centimeters. Since the problem identified it as being regular, that means all of the sides of our triangular base are also 10. Well, what do you actually need to know in order to calculate the area of a triangle? Okay. Big B is 1/2 times base times height, which will then multiply by the height of the prism, and then we still have this hemisphere going on over here. Okay, trying to figure out here in the parentheses 1/2 times base times height. Now this is of the base. Well, look at your base. Okay, base and height. What do we not know that we need to know? Need to know the height in there. Okay, and we don't have it. Absolutely, Pythagorean Theorem. Do we have two sides of a triangle to work with? You betcha. I got a 5 there. We got a 5 there. We can plug into Pythagorean Theorem. We got a 5 squared plus the height squared equals 10 squared, pardon me. Okay, when we clean this up, we're going to get 5 squared is 25. We'll subtract that to the other side. So we've got 100 on the other side. 100 minus 25 is 75. And then, of course, we don't want the height squared. We just want the height. So we would take the square root of both sides. And we have the square root of 75. Whatever that is, that's our value. So plugging that in to our formula we've got going on over here, you got 1/2. The base of our base is 10. The height of our base is the square root of 75. And then that needs to get multiplied by the height of the prism. And the height of the prism, as you can see from the diagram, 12. That is our prism. It'd be wonderful if that was the end of the problem, but it's not. Okay. We still have to figure out what's going on with the hemisphere. Okay. Well, let's see if we have the information that we need to figure it out. Obviously, 1/2 is constant. We don't have to worry about that. 4/3 is constant. Pi is constant. Radius. Okay, we need to be able to get radius from the figure, and that's all we need in order to plug in for the hemisphere. So let's look back at our problem and answer this question. Do we have the radius? We do not. Okay. The only information we seem to have about the hemisphere is that it has a great circle of 25 centimeters. Okay, well, there's that term we discovered the other day. What on earth is a great circle? It's the biggest circumference that a sphere has to offer. Okay, since we are dealing with a hemisphere, that's exactly half. The great circle occurs, for lack of a better way of putting it, at the equator. Okay, when we're dealing with a hemisphere, that's where it's split. Okay, it's split at its widest point. So what we need to do is we need to use the fact that the circumference of our hemisphere is 25 in order to calculate our radius. Yeah. So how do you find the circumference of a circle? Circumference is 2 pi r, straight off the formula chart. Okay. They gave us circumference as 25. Okay, just like we did on the homework from whatever it was, Tuesday. Okay, solve for r so that we can use the radius to solve for other things. So what are we going to do here? Divide that 2 out of there, divide that radius out of there, and we will end up with a radius of whatever 25 divided by 2 pi is. Okay. Now, as ugly as this is going to seem, here's what our formula just did. Our radius, we just said, was 25 divided by 2 pi, which according to the formula gets cubed. Okay. Well, as ugly as all that is, that's the end of our work. Then all we have to do is figure out what is going on with this. Well, let's go to the calculator and see if we cannot figure this thing out. For the part of the equation on the left, we've got 1/2. So I got 0.5 times 10 times square root of 75 times 12. And if you'd like to stop right there, which would probably be a good idea considering everything that's going on in this problem, we have 519.62. Now let's figure out what that thing is over there on the right. Probably the best thing to do would be kind of thinking about order of operations. Start where it's the ugliest. Come in here to this radius cubed, and let's do that. I'm going to open up some parentheses and say I've got 25 divided by 2 divided by pi. I'm going to close the parentheses. That is the radius. The radius needs to be cubed. Okay. You've got the radius cubed, which is this number. This number needs to be multiplied by pi and by 4/3 and by 1/2. So I can multiply times pi times 4/3 times 1/2. Okay, and you can do that in small pieces if it makes you feel any better. We'll come up with an answer, a number, 131.93. Okay, and then all we have to do is combine the two volumes that we had. So 131.93 plus 519. You've got the decimal points basically staring you in the face, so you can type a few more of them in there. Make sure we don't get a round off error or something. And we get a total volume of 651.54. And what was the units of measure? Centimeters cubed. Okay. Okay, that's about all the time that we have for today. We'll do the final example on Monday. So there is not an assignment. I wasn't planning on having an assignment anyway, because I simply know that this is going to cause us about 500 questions when we start to try to do it on our own. So we'll finish up the lesson on Monday, and then the assignment will follow that.